Hey everyone, welcome back to another video by Camroom 5. Today's video I'm making in order to answer so many questions about a certain topic, and that's going to be analysis of organic compounds. So before we begin, we should understand that there are various functional groups that are tested using various chemicals, which includes carboxylic acids that look like this. We have got the carbonyl compounds. So we have got carbonyl compounds. It could be an aldehyde which looks like this, RCHO, or it could be a ketone which looks like this, or you can have another carbon chain over here. We can have alcohols, and alcohols could be primary, secondary, or tertiary. So let's begin. If I were to test an organic compounds, I'm making a scheme and we can finally see which test fits ours. So let's see. In the beginning, you have an organic compound that you're not sure what it contains. So what you can do is, in step 1, you can add solid sodium carbonate. There are two possibilities. So let's draw it like this. There are two possibilities. Either it gives you effervescence or it gives you no change. If it gives you effervescence, it is a carboxylic acid. So carboxylic acid has been confirmed here. And if it does not give you effervescence, it's definitely not a carboxylic acid, but it could be aldehyde ketone, which means it's a carbonyl compound, or it could be any alcohol. Now, in order to test it further, the carbonyl nature, I would rather add 2,4-DNPH. 2,4-DNPH. Again, there are two possibilities. Either you get orange precipitates. If you get orange precipitates, it means your compound contains carbonyl. So it could be an aldehyde or ketone, or it could be a mixture of both. If you get no change, it means it's not a carbonyl compound. So it's not a carbonyl compound, which means not an aldehyde or ketone. Now it's most likely to be an alcohol. If you were confirmed about the carbonyl nature because of the orange precipitate with 2,4-DNPH, I would say add Fehling solution or add Tollens solution. Now, you could be getting, let me draw it a little smaller, you could be getting, if it's Fehling solution, you could be getting brick red precipitate, or you could be getting a silver mirror, or you could get no change. If you get no change, then the compound is likely to be a ketone. And if you get brick red precipitates or silver mirror, it means it's an aldehyde. Now, moving on, what if you had got no change with 2,4-DNPH? It means it could be an alcohol, right? So what could you do? You could add acidified manganate with a water bath. What would happen? Either you would get no change, or you would see it getting decolorized. If it's no change, it means it could be a carboxylic acid, but in the very beginning, where there was no effervescence, if it does not give you any effervescence with sodium carbonate, then just remove it. There's no carboxylic acid. It could be a tertiary alcohol. It can't be a ketone because remember, we have already tested with 2,4-DNPH and you haven't gotten the color. So follow this scheme, right? So it's a tertiary alcohol. It's not secondary, it's not primary. If it does decolorize, it means it could be a primary or secondary alcohol. It could be methanoic acid, which looks like this, because methanoic acid is an exception. It's an exception because it will give you effervescence and it will also give you decolorization with manganate. So this is the scheme that you can follow. Now, quick reminder about what these chemicals are. When I said manganate, you should know manganate is a strong oxidizing agent which gives you a color of purple, which gives you a change of purple to colorless. Another thing, when I talked about Fehling solution, so you should know that Fehling solution is copper 2 sulfate and organic acid. So Fehling solution contains copper ions. You should also know what's Tollens solution. So Tollens solution is basically ammonical silver nitrate. It is also known as ammonical silver nitrate. So this is the scheme that you can follow for organic analysis. Stay tuned, guys. Thanks.